In part one of our examination of the innate immune response, we will focus on how cells of the innate immune system are able to recognize pathogens and induce an inflammatory response. The innate immune response is composed of physical barriers like the skin and the mucosa, but it's also composed of cellular barriers, and these cells of the innate immune system are able to recognize pathogens directly. And this recognition of pathogens leads to the production of inflammatory cytokines and the activation of the complement cascade. Once inflammatory cytokines are produced, this leads to vasodilation of local capillaries and cellular infiltration and the local inflammatory response, which is mediated primarily by cells of the innate immune system, such as phagocytes like macrophages and neutrophils, and natural killer cells, which can mediate potent antiviral effects. Once the pathogen is controlled and the inflammatory response begins to wane, many cells of the innate immune system, such as macrophages, produce immunosuppressive cytokines, leading to a wound healing and tissue repair response that resolves inflammation. There are also cells within tissues, such as dendritic cells, that are able to capture pathogens or pathogen products, migrate to draining lymph nodes, and activate T cells and induce the adaptive immune response, which leads to the production of antibodies, direct cytotoxicity, and the formation of immunological memory. Today, we will focus primarily on the concept of how innate immune cells are able to recognize pathogens. I've shown here an epithelial barrier. This epithelial barrier could be your mucosa, it could be skin. In this case, the epithelial barrier has been compromised and a pathogen, or like a bacteria, is now within the tissue. There are a couple of different ways in which this pathogen can be recognized. One is that the pathogen can directly trigger the activation of the complement cascade, shown here. We will talk more about the complement cascade in the next video. The other way that cells in the innate immune system can recognize this pathogen is through pattern recognition receptors. To understand pattern recognition receptors, we first have to understand that pathogens have unique structures recognized by the immune system, and these structures, or molecular motifs, are often referred to as pathogen-associated molecular patterns, or PAMPs. One of the most well-known of these PAMPs is lipopolysaccharide, but there are a number of them. They include lipoproteins, cell wall products like peptidoglycan, other structural proteins like flagellin, in the case of fungi, a variety of sugars, and then unusual nucleic acid structures. In the case of viruses, this can include double-stranded RNAs in the cytoplasm or uncapped single-stranded RNAs. These PAMPs can be recognized by a variety of receptors, or a class of receptors in the innate immune system, that are collectively referred to as pattern recognition receptors. I've shown here a number of pattern recognition receptors that are present on the cell surface. Pattern recognition receptors can also be present in endosomes or even in the cytoplasm. And at these various locations, they can recognize a variety of different molecular motifs that are unique to pathogens. The most well-known pattern recognition receptor family is the toll-like receptor family, and I've shown the toll-like receptor family here in this slide, as well as many of the products that are bound to by various members of this family. Now, I don't really want you to spend time memorizing the different toll-like receptors and the specific molecular patterns that they bind to. Instead, we're going to focus on a single toll-like receptor and a single PAMP, lipopolysaccharide, as our kind of canonical example of how toll-like receptors initiate an inflammatory response. Lipopolysaccharide is present on the surface of bacteria, not all bacteria, but many bacteria, and can also be secreted. And when lipopolysaccharide binds to toll-like receptor 4 on the surface of innate immune cells, this can trigger an inflammatory response. This inflammatory response is triggered because that binding induces a kinase signaling cascade, which in turn activates transcription factors that drive the production and secretion of inflammatory cytokines. there are a number of inflammatory cytokines that are produced, but for our purposes, we're going to focus on the ones that are listed here: interleukin 1, tumor necrosis factor, interleukin 6, and interleukin 8. I'm not going to get into many details in the innate immunity TBL regarding these inflammatory cytokines, but we will have a separate session where we will discuss their functions in greater detail. So now let's go back to the tissue. We've got a macrophage. It's expressing a toll-like receptor. This toll-like receptor is recognizing some molecular pattern expressed by this pathogen, leading to the production of inflammatory cytokines. These inflammatory cytokines are now going to initiate the local inflammatory response. That includes endothelial cell activation, capillary vasodilation, and inflammation, which we will talk about in a later video.